right. Any questions on any of the problems from the worksheet? Once again, it is a second day of what we've been dealing with. So you should be somewhat comfortable with what we were working with. Is there anything you still need me to go through with respect to vectors and bearing and working with vectors and bearing?
Can you do number 5?
Number 5. The plane travels on a bearing of 110 degrees. So we have a bearing, we have 120 miles on a bearing of 110 degrees, and then turns and travels 200 miles on a bearing of 240 degrees. So we're going to get our axis down first. Once again, when dealing with bearing is you have a north reference, and we are rotating Mickey's big hand 110 degrees. So if we rotate, whoopsie, let's try rotating. Rotate, here would be 90 degrees. So 110 degrees would be somewhere down into here. Oops. So this would be your 110 degrees. Now what I suggested that you do is draw yourself a little axis at the tip. And do the exact same thing with the second bearing. Okay, so we have a bearing of 240 degrees. Okay, so we start here. This is our 0 degrees. This is our north reference. And we're going to rotate 240 degrees. Well, if we rotate 240 degrees, this would be 90 degrees. This would be 180. This would be 270. So 240 is going to take me into here somewhere. And that one's 200 and some miles. So I'm going to extend this a little bit further. And this is a rotation of 240 degrees. And let's see, let's get some lengths in here. This is 120 miles. And this is 200 miles. And what we want to calculate or determine is what is the distance and direction from the initial position. So here is our resultant vector. Victor? So we know 3 sides of a triangle. We know 2 sides of a triangle. We want to find the third side. Well, to find the third side, we need to know that included angle between those 2 sides. Okay, so we need to calculate this included angle right here between the 2 sides that we know, so we can find VR. Well, that included angle we have to do in little pieces, parts. Okay, if we rotate this 240 degrees here, this is my rotation of 240 degrees. What is this small pieces part here? This rotation is 240. What's that leave for this? Braden, what does that leave for this angle here? If this is a rotation of 240 from here to here, what's that leave for this angle right here?
I'm not sure.
Well, what if I would rotate? Let's think about this. Okay, think about what we did here. We started here. We rotate 90. We rotate 180. If I rotated to here, that would be 270. But I only went 240 degrees. So how many degrees did we go back?
Oh, would it be 30?
30 degrees. So this is 30 degrees. Okay, the other part is this angle right here. Now, once again, we look at the idea of parallel lines. We have horizontal lines here, so that we have this horizontal line, and we have this horizontal line here. And then we have this vector, it's going to be a transversal. Well, this is a rotation of 90 degrees. Well, we went 110 degrees, so how many more degrees do we have to go to get to this point? Emma, how many more degrees do we have to go? Ooh, this was 90 degrees to here. This is a total 110. Well, so what's this angle have to be? This rotation is 110 degrees. This is a right angle. So what's that leave left for this?
20 degrees.
20 degrees. So if this is 20 degrees, we have the horizontal lines that are going to be parallel. We have a transversal here. We can look at alternate interior angles. So if this is 20 degrees, that means that this has to be 20 degrees. For a total of 20 and 30, which is 50 degrees. So now we know two sides, the included angle. Set yourself up a law of cosines equation to find VR. So we should have VR squared is equal to 200 squared plus 120 squared minus 2 times 200 times 120 cosine of 50 degrees. And if you have the 200 and 120 switched around, that is fine. Isaac Wenger, what do you come down to for VR?
153.45.
153.45. And those are miles. Now, the problem we run into here, we always want to calculate the angle at the original origin. This is your alpha value. The problem we run into here is this alpha value is across from the biggest side. I have 120, 153, and we have 200. So the problem we run into is if I use my law of sines, we won't know if this is supposed to be the supplement or the original angle, the principal value that we come out with our angle or out of our calculator. So what we should do when we see we're across from the biggest side is use your law of cosines, because your law of cosines will always get you the correct answer because there's only going to be one of them. So if we have the cosine of alpha at the end, what's opposite that's going to be the 200 squared at the beginning. Then we have the 153.45 we just calculated, plus 120 squared minus 2. I should have left myself some more room. 2 times 153.45 times 120 cosine of alpha. So this one is a little bit more maintenance. It's a little more high maintenance just because we don't know for sure this alpha value, what it could come down to. If it came down to like 75 degrees, well, it's 75 or 105. Which one do you pick? You don't know which one you pick, 75 or 105. If it comes down to 80 degrees, is it 80 degrees or 100 degrees? You don't know which one to pick. So the law of cosines will take care of that for you. So we can subtract off our 153.45 squared, subtract off our 120 squared. On the right-hand side, we can multiply the negative 2 times 153 times 120 and get a coefficient. Once again, you have to have patience as you go through these problems. We have 2053.8 here. I want to put a 0.81, that is fine. Then we have negative 2 times 153.45 times 120. We get negative 36.828 here, I think. And we can divide by the negative 36.828, which will cancel those out, and then take the inverse cosine. Cosine. And what you come down to is an angle of 93.2 degrees. Which is the measure of that angle. Once again, what your law of sines would have came down to would have been 86.8. So you have 86.8 or its supplement 93.2. You don't know which one you would use. So that's why when you're crossing the biggest side, you should use your law of cosines to find that angle, because that will give us a definite. And then our bearing, well, our bearing is, this is 110 degrees. This here is 93.2, so we can add 110 to that. So we get 203.2. Other questions? Once again, as I related to earlier, you need to have patience as you go through these problems. There is, when you get to upper level mathematics, as we're going into upper level mathematics here, there's really not a snap your finger quick answer to a problem. Okay, there's parts that are snap your finger, get a quick answer. That's your inverse sine or inverse cosine. But to be able to set up, to be able to get that, this takes some work here. This takes some work here. This takes some work here. Okay, it takes work to be able to get to that upper level, the upper level math and the solutions to a problem. Other questions? All right, your review sheet, same types of problems on your review sheet, but the initial couple problems are you just drawing graphically a solution. Where I give you, if you pull out your review sheet in your packet, you have 3 that you have to draw graphically. The first one says draw A plus B. Now, when doing this, you want to try to maintain the length of the vector. So whatever the length is, you want to try to maintain that length in that direction. You want to try to maintain the length and also the direction of that vector. What I typically will do when I'm trying to maintain these lengths and directions, go. All right, you able to see me now?
Yep.
Yeah, right. There we go. Sorry if I was a little too close for you. I was a close talker there for a second. I got to keep my 6 feet, maintain my 6 feet distance from you, so I'm going to back up a little bit. Typically what I will do is I will take a sheet of paper, fold it in half, and fold it in half one more time. Then what I will do with this is with a pen or a pencil on this piece of paper, put a little mark at the beginning and end of the vector. That's A. And then for vector B, once again, do my length on the piece of paper. So my little piece of paper has some hashes on there. Okay. Then from that point, I want to draw vector A. So I'm going to slide and be horizontal as best as possible and draw vector A. Okay, so I just drew vector A. Then when I want to draw B, I will go up here to B, and I will slide it down. I will get my direction there and slide it down to my vector and draw the length B in there. So now I have my A plus B in there. Okay, make sure you put your arrows at the end. There was A and there was B. So I have A and B there. The final thing is to draw the resultant vector, the big bad wolf's path to grandma's house. So big bad wolf is once again going the same direction. So I draw my second or my resultant vector in. Make sure I'm starting in the same spot and ending at the same spot. Okay, so your resultant vector then has to get drawn in. If you don't draw the resultant vector in, then you just said 5 plus 4 is equal to 5 plus 4. You need to make sure you get an arrow also in the right direction. It is not a continual arrow going around a triangle here. we had vector A, which traveled from here to here. Then vector B traveled from here down to here. That was Little Red Riding Hood's way to Grandma's house. The result vector is the Big Bad Wolf's way, so we draw in from here down to here, but we need to make sure we get our arrow here at the very back end of this. Okay, so we need to have, we are starting in the same spot, we are ending in the same spot with these two directions. Okay, it's like if you're driving to Worcester from Dalton, you can hop on Route 30 and cruise on Route 30. Heard there was an accident there today, so you probably want to stay off 30. You can cruise down Route 30 to get to Worcester. Or if you wanted to, you could drive, and that would be the Big Bad Wolf's way of getting there. Or you could go down 94, go to Church Road, take Church Road to Orville, go through Orville, then maintain the back Orville Worcester Road and get to Worcester also. There's more than one way to get to Worcester. Okay? Well, there's more than one way to add these two vectors together, Victor, get a result. Okay, I start here and move here. That's your A, that's Little Red Riding Hood, and then B. And then we have Big Bad Wolf, which is a straight line distance between A and B. So if we take a look at problem number 3, you have 2A plus B. So we want 2 of these A's. So I'm just doubling my length. So here's my 2 A's, maybe. And then we want to add in B. So once again, I want to maintain my length and direction. That's why I'm using that piece of paper. There is my B. And then we draw in the resultant vector, Victor. Now if you want to use a different color, that's fine, I do. Just to be fancy schmancy. But once again, this is the result vector. This is the Big Bad Wolf's way to get to Grandma's house. This is Little Red Riding Hood. She's going here and going down here. You need to draw in the result vector when you're dealing with these. Okay, the other 2 sets of problems are just what we've done on the worksheet the last couple days, where I give you an angle between 2 vectors. You got cat and dog going on there. They're connected at their tails. And you start throwing numbers in there. I give you an angle and lengths of the vectors, Victor. And then you have a couple bearing problems at the very bottom. Once again, quiz will be on Tuesday. The quiz will be on Tuesday. And the times, once again, have been altered. So on Tuesday, we have the quiz. And this is 4th period, so we will go from 9:15 a.m. to 10:15 a.m. Questions you have? All right, my goal was just to come in and go over this real quickly as best as possible and give you the rest of the time. If you have any questions, feel free to comment me or email me. I'll try to help you out as best as possible. Other than that, I have nothing else for you. Have a good weekend. Stay safe. Stay out of trouble. If you're out driving around, stay safe. Keep your social distancing out there. If you have nothing else, we are done for the day. Done for the weekend. Everybody have a good weekend. Adios.
All right, thank you, Mr. Gregory.
Yep.
Bye.
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 Adios, amigos. Estudiantes.
Hey, Mr. Gregory, sorry I was a little late. That's my fault. I caught it. I caught the end of it though.
All right. Well, if you miss it, it will be screencastified, and you can capture the whole lesson if you
Yeah,
want.
I'll look over that.
Okie doke.
Thank you. Appreciate it.
Yep.